Hi students. So as the extension of the topic, we are going to discuss about uh, how do you find the focal length of a concave mirror. That lab activity we are going to discuss in today's class. Okay, we are going to see in a step-by-step manner how we are going to find the focal length of a concave mirror by using laboratory equipment. Okay, so our topic is, so what is our aim? To find the focal length of a concave mirror is our aim. Okay, now we are going to see what are the materials required for this experiment. We require a V-shaped wooden stand to keep the concave mirror, and obviously we require a concave mirror. We require a screen to catch the image. We require a meter scale to measure the distances. We require a candle as a source of light. Obviously we require a matchbox and pencil. Okay, so what are the materials required by us? V-typed or V-shaped wooden stand, the concave mirror, screen, meter scale, candle, matchbox and pencil. So now we are going to look at the procedure of conducting the experiment. So what are the procedure required? First of all, we are going to draw the diagram in the procedure. First we will draw the V-shaped wooden stand. So this is our V-shaped wooden stand. On the top of this stand, we are going to place a concave mirror. So this is the concave mirror. And now here we are going to place a scale. This is a meter scale. Okay, you understand? This is the scale. Here we are going to place a candle. Okay, and here we are going to keep the screen. Okay, right. So you all know that we are going to have the image like this. Now you should have to understand here the distance between the mirror and the object, that is source of light, is technically called as U, stands for object distance from the mirror. The distance between the mirror, this point, as well as the image, this point, is what we called as image distance, denoted by the symbol V. So you should understand U and V. We are going for the value of F. How to find the value of F? F stands for focal length. Okay, so now we are going to, in the procedure, we are going to draw the diagram. After drawing the diagram, we are going to write, arrange the equipment as shown in the figure. We are going to arrange the equipment as shown in the figure. Then what we are going to do is, we are going to adjust the position of the candle. Okay, we are going to move the position of the candle here and there, such that we can have a sharp image on the screen. That is what we are going to write here. Adjust the position of the candle such that we can have a sharp image on the screen. So adjust the position of the candle such that we can have a sharp image on the screen. And now you have to understand that the distance between mirror and the candle as u. Measure the distance between mirror and the candle as u, and measure the distance between image and the mirror as v. So we are going to repeat this experiment at different positions, okay, like 3-4 trials we are going to do it. So I'm going to write the same. Repeat the experiment at different positions, and the observations are tabulated. Okay, now see what we have written here. Arrange the equipment as shown in the figure. Adjust the position of the candle. We are going to adjust the position of the candle such that we can able to have a sharp image on the screen, because considering of sharp image is important here. And now we are going to measure the distance between these two as u and these two as v. And we are going to repeat the experiment as we are going for different trials. Repeat the experiment at different positions of the candle, and every time we are going to note the values. So now these values are going to be noted in observation thing. Okay, now we are going to write observation. In observation we are going to draw the table. So here we are going to draw the table. So what are the values that we are going to write in the table? This is for serial number. This is for u. This value will be in centimeters. This is for v. This is also in centimeter. Here we are going to write 1 over u. Here we are going to write 1 over v. In the last we are going for 1 over u plus 1 over v. 1 by u plus 1 by v. Okay, let us assume that we are going for 5 trials. Here different positions like 20 centimeters, 30 centimeters, 40 centimeters, 50 centimeters, 60 centimeters. As we conduct the experiment, we are going to have the values, different values we are going to have. After observation, we are going to write result analysis. Result analysis. So what we can analyze from this? So see, at different positions of the u, we are going to have different positions of the v. Obviously 1 by u value will be different and 1 by v value will be different, but in all the cases it is surprising that the 1 by u plus 1 by v value will be approximately constant. You are going to find the value of 1 by u plus 1 by v will be constant. That is what I am going to write here. From the above table, we can observe that 1 by u plus 1 by v value will be constant. Okay, after this what we are going to write? We are going to write the generalization. So what is the generalization? This is our formula. From the formula, 1 by f equals to 1 by u plus 1 by v, we can find the focal length of any given concave mirror. The precaution we are going to write measure the distances accurate. It is a very important question for you. I think you have understand. So look at the aim to find the focal length of a concave mirror. Materials required: the V-type or V-shaped wooden stand, concave mirror, screen, meter scale, candle, matchbox and pencil. Procedure: first of all you are going to draw the diagram, and then we are going to write arrange the equipment as shown in the figure, adjust the position of the candle such that we can have a sharp image on the screen, measure the distance between mirror and the candle as u, and measure the distance between image and the mirror, that image means the screen, and the mirror as v, and we are going to repeat the experiment at different positions of the candle, and every time we are going to observe the observations, and they are going to be tabulated. So observation is going to have a table, serial number u, v, 1 by u, 1 by v, 1 by u plus 1 by v. And the result analysis is, I told you that in all the cases we find 1 by u plus 1 by v value will remain approximately constant. And from the formula 1 by f equals to 1 by u plus 1 by v, we can find the focal length of any given concave mirror, and this formula is what we called as mirror formula. So this formula is called as mirror formula. In the next class I am going to tell you how to derive the mirror formula, means how we obtain this can be called as a mirror formula. And now I am going to tell you how to find the focal length of a concave mirror without using the above experiment. That means like the candle is not used, everything is not there. Now you have a concave mirror. So take this concave mirror and stand in the front of sunlight. Okay. Now I told you that sunlight is the best example of infinite source of light, and infinite source of light is going to produce you parallel beam. Okay. Now if all these rays are parallel from the sun, then as we have discussed, all these should be intersect at a point called as F. Am I right or wrong? All these rays are intersecting at this point. So if we are going to take a piece of paper and we are going to place the paper here, then the paper is going to burn. Are you understanding? Because the parallel rays are going to intersect at F, and by taking the help of a scale we can measure the distance between this point and this point, and this is what we call as focal length. That means focal length can also be obtained in the presence of sunlight. Okay, if you are going to take a piece of paper, a concave mirror, and you are going to stand in front of sunlight, and we can have the image of the sun, the point sharp image of the sun on the piece of paper, then with the help of a scale measure the distance between that point to the mirror is going to give you the value of focal length of the mirror. Okay, so focal length can be obtained from two ways. This is way number 2, and the first one is the lab activity way, where we are going to have 1 by f is equal to 1 by u plus 1 by v, which is called as mirror formula. In tomorrow's class we are going to discuss about the derivation of the mirror formula, and we are going to discuss about sign convention. How to go for the sign convention is a very important topic that we are going to discuss in tomorrow's class. Hope you understand the class. Please do like and subscribe the channel. Thank you.